Welcome back. Now we have the ability to play an attack montage from blueprints, but we want to do this from C++. So we have a couple of steps to go through. The first thing I'm going to do is go back to our character blueprint. We no longer need these nodes, so we can highlight them and delete them. Instead, let's jump into our C++ project. The first thing we need to do is make a callback function to bind to our attack action mapping. So here in /character, I'm going to make a protected function for this, and we'll place it right here next to our other action and access mappings. This will be a void function called attack. So I'm going to implement the attack function, and here it is. And before we do anything in attack, let's bind this to the attack action mapping. We'll go up to Setup Player Input component. And here we have two functions bound to action mappings, jump and equip. So I can copy one of these lines, such as our binding of E key pressed. I'm going to go ahead and paste that and change the text for the F name to attack and change the function to a/character attack. And now our attack function is bound to the action mapping called attack. Now we want to play an attack animation here in attack. And that means from C++, we need a variable for the animation montage to play. So in /character.h, we're going to add a variable for the animation montage. And we'll add this down here in our private section. Now, since we may have multiple montages in the future, I'm going to go ahead and make a multi-line comment here. And this will say animation montages. And we'll keep our montage variables down here. Now, the data type for an animation montage in C++ is uAnimMontage. We're going to make a pointer of this type called attack montage. Now, we can forward declare this type all the way up at the top with our other forward declarations. So we'll say class uAnimMontage. Now we can use this type down here. Now, this is a variable. How are we going to set it? Well, we could choose an animation montage from the character blueprint if we expose this to blueprints. So let's give it a U property. And I'd like to be able to set this from the default blueprint of the character. So I'm going to give it edit defaults only. And we can give it a category while we're at it. I'll place it in the category montages. That way, as we add more montages, we'll add them all to this same category, which will make it easy to find these in the details panel in the default blueprint. Now that we have a variable for this, it's time to play a montage from our attack function call. Let's go back to attack, and let's figure out how to do this. Now, we've done it in blueprints already. We saw that we needed to access the anim instance, and we could get that through the character mesh. So what we're going to do is call getMesh. This will return our skeletal mesh component. And from the mesh, we can get the anim instance with a public getter function called getAnimInstance. And hovering over this, we see that it returns a uAnimInstance pointer. Now we can go to the Unreal Engine documentation by simply searching Google for uAnimMontage. And we're taken to Unreal Engine documentation. Here's the class with lots of information about the functions and variables, and here's our include, animation/animmontage.h. We're going to copy that and paste it at the top of /character.cpp. And now we can use this type. So we're calling getAnimInstance, which returns a uAnimInstance pointer. We're going to store this in a local variable. So we'll make a uAnimInstance pointer called animInstance and store the value returned from getAnimInstance right into it. Now, as soon as we do this, we should check to make sure that the animInstance returned isn't a null pointer. So we'll say if animInstance and check that first before we access it. And we can take our animInstance, and just like in blueprints, there's a montage play function. In C++, it's montage_play. Now we can start the opening parentheses and see the input parameters here. And notice they're the same as the inputs we saw in blueprints. The first is the actual montage to play. And notice it's a uAnimMontage pointer. We created a uAnimMontage pointer, as a member variable called attack montage. So we're going to pass that in. So our first input is attack montage. But we have to keep in mind that we're planning to set this from within the character's blueprint, as we made it edit defaults only. And if we never bother to set this, it'll be a null pointer. So we should also check to see if that is not a null pointer as well. So we'll place an and here and say and attack montage. And we won't make it into the if check if the attack montage is a null pointer. Now we can add a comma and see that the rest of these input parameters have default values. The play rate is 1, the montage return type is montage length, just like it was in Blueprints. The time to start the montage at is 0, just like in Blueprints. And the Boolean stop all montages is true, just like in Blueprints. So we can leave all the rest of those inputs out of it. Now the question is, do we want to jump to a montage section? We know that our montage has 2 sections. Now let's say we'd like to jump to a montage section at random. We could do this by generating a random number. Let's make an int32 called selection. And we can initialize this using a function on the fmath library called randRange. And if we choose the randRange function and open the parentheses, we'll see that this takes 2 numbers, a min and a max, and returns a number of that type. And there's a version of this that takes doubles, but if we go through the overloads by clicking the down arrow, we see that there's a float version, as well as an int64 version and an int32 version. So we could pass in integers here. Now we see that it says returns a random number greater than or equal to min and less than or equal to max. So we can use 0 for the min and 1 for the max. And this is basically a coin flip. It'll return 0 or 1 randomly. So we can choose an animation section at random based on our selection. A switch statement is good for this, so we can say switch, and we're switching on selection. And if you're not familiar with a switch, it'll execute one thing based on what we pass into the parentheses. And we choose the thing that happens by adding cases. We can say case 0 with a colon, and we can say case 1 with a colon. And any code that we place after case 0 will be executed if selection is equal to 0. If it's equal to 1, then we'll get the code in this section executed instead. And if it's neither of those, we can always have a default section and place code there if we want it to execute if selection is not equal to any of the cases that we've implemented. Now, if selection is equal to 0 and we execute any code in the case 0 section, then as soon as that code is done, the switch statement will move to the next section by default and start executing that code unless we place a break at the end of the 0 case. So it's pretty common to place a break at the end of each case in a switch statement. So what do we want to do in our switch statement? Well, we'd like to jump to a section, and to jump to a section, we need the section name in the form of an fname. So an easy way to set the name based on the case is to create an fname variable outside the switch statement called section name. And to make sure it's never uninitialized, we can set it equal to an fname, which is empty. But we can overwrite the value based on the value of selection. If it's 0, we can set section name equal to an fname with the value of attack1. And if selection is equal to 1, we can set section name equal to an fname with the value attack2. So now we have a section name fname variable set to attack1 or attack2 at random. Now after the switch statement, as long as our section name is set, we can jump to a section. And we do that by taking our anim instance and calling montage jump to section, just like we did in Blueprints. And notice the first input is the section name. We're going to pass in our local variable, section name. And we can pass in the animation montage. We're going to pass in our attack montage. So now we'll play one of the animations at random, attack 1 or attack 2, based on our random integer selection. So now that we've implemented our attack function in C++, we can compile this. Now I'm going to go back into the editor and close out of it, saving everything, and do a hard compile from Visual Studio with Control-Shift-B and see if we get a compile. Now I do see that I have a compiler error, /character.cpp line 130. And that's because we have a default section with nothing in it, so we do need to put something there. I'm going to simply place a break statement. Now I can compile, and with a successful compile, we'll go ahead and launch the editor. So now with the editor launched back up, there's one thing we need to do. I'm going to close project settings and open up Blueprints, Characters, BP/character. And remember, we added a variable for the animation montage. And we placed it in the Montages section, so let's look for that. Here it is, Montages, and it's called Attack Montage. And we made this Edit Defaults Only, so it's exposed and editable right here in the default blueprint. So I'm going to select AM Attack Montage for this, compile, save, and press play. And I can grab a weapon. In fact, I don't need to grab a weapon. I can simply left-click and I'll play the montage anyway, as we're not placing any checks to see if we have a weapon. But if we do grab a weapon and left-click, then it looks better. And this is great because we're now playing sections of our montage at random, based on that selection random integer. So this is a nice way to add some variation to the game. Excellent. So we're one step closer to having functional combat, but there are some issues. For one, we can spam the attack button and we'll start playing montage sections right away before the last montage section was finished playing. So that's a problem we'll need to address. Now another issue is that we'd like our weapon to have different behaviors based on its state. Now we don't have any enums on the weapon for its state, but we could, and that would allow us to have different behaviors, such as letting the weapon hover up and down if it hasn't been equipped yet, and we can make it stop hovering as soon as we equip it. So there are a few details we want to take care of when it comes to our weapon and our character's states, and we'll take care of those in the videos to come. I'll see you soon.